Hi, welcome to Nomis Academy. Today we'll be dealing with approximation. Now, today we'll be dealing with three types of approximation. Number one, we'll be dealing with approximation to the nearest whole number, to the nearest whole number. To the nearest whole number. Approximation to the nearest whole number. So let's take for an example, example A. Example where we're asked to approximate to the nearest whole number 7.8126. So we need to approximate 7.8126 to the nearest whole number. Now, how do we consider approximation? We consider approximation by a digit to which approximation we are doing. Now, this is what I'm talking about. Since this is talking about the nearest whole number, I know that this is where I have whole number. Everything I have behind this whole number are decimal numbers, right? So these digits are decimal numbers. So I can say that, and you don't say 8,126. You say 7.8126. Anything that comes after points should be read one after the other, not as a O. Do you get it now? Now this is 7.8126. So what I need to consider is the digits before that whole number. The digits before that whole number. So 8 is the digit before that whole number. And looking at 8, is it up to 5? Once the number is up to 5, you approximate it to be 1 and add it to the nearest whole number. It is not up to 5, it is approximated to be 0 and added to the nearest whole number as well. So since it is up to 5, so since this 8 is up to 5, I can say I approximate it to be 1 and add it to this 7, which is the nearest whole number, and the nearest whole number to tell after this approximation is 8. So that 1 plus 7 is 8. So I just approximated 7.8126 to the nearest whole number. So let's take another example. Example 2, example B, 8.174. So approximate 8.174 to the nearest whole number. So how do I get this done? The same thing I did in the first one. So I have 1 here. I'm not concerned with this ones. I have 1 here. So 1 is what I will consider to approximate to the nearest whole number, since this is where I have the nearest whole number. So the number before the nearest whole number is what I consider, since it's just 1 and it is not up to 5. Therefore, I approximate it to be 0. So 0 plus 8, I will have 8. So this to the nearest whole number is 8. So 8.174 to the nearest whole number is 8. So let's take another example. The third example here, we have 15.62 approximates to the nearest whole number. So when I look at it, I consider that digit before the whole number. This is 6, it's up to 5, so I approximate to be 1 and I write 16. So this I just did approximation to the nearest whole numbers. Are you getting it now? So let's take another one, part 2. This is saying to approximate to 3 significant figures to three significant figures. To 3 significant figures. So let's take them one after the other. We're still going to use the same digits that we have at the top, 7.8126. So how do I approximate to three significant figures? So we are talking about figures. We are less concerned about the decimal point or whatever. So let's start reading from the left hand side. 7, 8, 1. So these are the three significant figures. But before we put down the three significant figures, we will now consider the digits after that one, after that three significant figure, to tell if it is up to 5, we approximate to be 1 and add it to the next one by the left. But if it is not up to 5, we still approximate to 0 and add it to it. No, anything added to 0 remains the same, right? So since we have 2 before 1, which is the third significant figure of this number, then we approximate 0 to be, we approximate 2 to be 0. So this becomes 7.81. We only have three significant figures here. So this is 7.81 to three significant figures. Let's take option B. 8.174. So three significant figures, 8.174. So 8.17. Since 4 is not up to 5, I will take 8.17. So let's take the third option. 15.62 to three significant figure. 15.67. 16.67. So looking at this 15.67, I have 7 here. 1, 2, 3, 6 is the third significant figure. So I have 7 behind 6. Definitely I will need to approximate 7 to be 1 and add to it. So I'll have eventually 15.7. I have 15.7. So let's take the third one. To 2 decimal place. Approximate to 2 decimal place. To approximate to 2 decimal place. Now to approximate to 2 decimal place, let's take them one after the other. The first one, A, is 7.8126. So to 2 decimal place, that is, after the decimal point, we only need 2 digits. After the decimal point, we only need how many digits? 2 digits after the decimal point. 2 digits after the decimal point. So I can write 7.8, but before the second decimal point decimal place number digits, I must consider the third one to know if it is up to 5. If it is up to 5, I will approximate it to be 1 and add it to the one I want to write now. Are you getting it now? The digits are the 2 decimal place. Are you getting it now? But if the one at the third decimal place is not up to 5, I will still approximate it to be 0 and add 0 to it. That means it will remain the same. So let's check for this. I have 2 here at the third decimal place. So since 2 is not up to 5, that is 0. 0 plus 1 will be 1. So I'll be left with 7.81. So the second one, 8.177. So to 2 decimal place, I will say 8.1. Now the digits before decimal point is 7. So the third one is 7 too. Since it's up to 5, I will approximate it to be 1 and add it to it. So this becomes 8.18 to 2 decimal place. Now here I have 15.62. The question is already in 2 decimal place. What am I going to do? Then it remains the same. Since it's still asking me to leave it to 2 decimal place, so it will be 15.62. 15.62. Nothing to consider to put it into decimal place. So it is 15.62. I hope you enjoyed the class. Bye bye. See you in the next video.